acetone alcohol, this is ketol. Diacetone alcohol on heating loses a molecule of water to form acetyl oxide. The reaction is CH3COH CH COCH3 CH3. On heating, it loses a molecule of water using this OH and H to release the compound acetyl oxide 4-methyl pent 3-ene 2-one along with the formation of water molecule. Next, in the presence of dry hydrogen chloride gas, acetone molecules condense to form a mixture of acetyl oxide and 4-one. The reaction is 2 molecules of acetone in presence of dry hydrochloric acid gas. It loses a molecule of water to give acetyl oxide 2-methyl pent 3-ene 2-one. In excess of acetone molecules, that is for say in presence of 3 molecules of acetone, they react in presence of dry hydrochloric acid gas, loses a molecule of water to give the compound 4-one. Note that here the unsaturated compounds is isolated and not the aldol or ketol. Next, acetone forms acetylene, that is 1,3,5-trimethylbenzene on distillation with concentrated sulfuric acid. The acetone, when treated with concentrated sulfuric acid, it gives acetylene plus 3 molecules of water. Again, it is an unsaturated compound that is isolated and not the aldol or ketol. Now the next, mechanism of base catalyzed aldol condensation. Well, here let us take the example of the condensation of 2 acetaldehyde molecules. The reaction takes place in the following 3 steps. In first step, the base OH ion removes a hydrogen ion from alpha carbon atom of one of the aldehyde molecules to form the resonance stabilized carbanion. This is 1. Acetaldehyde, the first molecule, it gives carbanion. This is 1. In second step, the carbanion 1, this is enolate, being a nucleophile, adds to the carbonyl carbon atom of the second molecule of acetaldehyde to form anion of aldol. This is acetaldehyde second molecule attached with carbanion 1 to give anion of aldol. In third step, the aldol anion now takes a proton from the solvent, that is water, forming aldol. The anion of aldol, it takes water to form the aldol. Important to note here that the catalyst OH ion, hydroxyl ion, is regenerated in this step only. Next, the mechanism of acid catalyzed aldol condensation. One of the aldehyde molecules undergoes enolization, which then attack the protonated carbonyl group of another aldehyde molecules. Beta hydroxyaldehyde or ketone so formed undergoes dehydration very easily, forming a double bond at beta carbon atom, leading to alpha beta unsaturated aldehyde or ketones, which is quite stable due to conjugation. The example reaction CH3CHOH, CH2CHO, this is aldol. When warm in presence of dilute HCl, it gives CH3CH double bond CHCHO, this is crotonaldehyde. If the double bond is in conjugation with the aromatic ring, the product becomes so stable that unsaturated aldehyde or ketone is isolated as the final product instead of beta hydroxycarbonyl compound. For example, in the reaction C6H5 C double bond OCH3 plus CH3CO C6H5 in presence of C2H5ONA, it gives C6H5 C CH3OH CH2 C double bond O C6H5, which loses a molecule of water to give C6H5 C CH3 double bond CH C double bond O C6H5, that is 1,3-diphenyl 2-butene 1-one. Next, intramolecular aldol condensation, that is cyclization via aldol condensation. A dialdehyde or ketoaldehyde or a diketone undergoes aldol condensation to form 5 or 6 membered cyclic compound. This is oxoheptanol in presence of base. It gives 1-cyclopentenyl methyl ketone. In this ketoaldehyde, although 3 different enolates are possible, it is the enolate from the ketone side of the molecule that adds to the aldehyde. This is because of greater reactivity of aldehydes towards nucleophilic addition than the ketone due to electronic as well as steric factors.